In the previous section, we showed that electromagnetic waves propagate out away from accelerating charges at the speed of light. The speed of light is very fast, but it is finite. For example, it takes just over a second for light to travel from the Moon to the Earth, a distance of about 240,000 miles. Because of its high speed, early attempts at measuring the speed of light had only limited success. One of the first accurate measurements employed a rotating mirror, and the figure shows a simplified version of the setup. It was used by the French scientist Jean Foucault, and later in a more refined version by the American physicist Albert Michelson. If the angular speed of the rotating 8-sided mirror in the figure is adjusted correctly, light reflected from one side travels to the fixed mirror, reflects, and can be detected after reflecting from another side that is rotated into place at just the right time. The minimum angular speed must be such that one side of the mirror rotates 1/8 of a revolution during the time it takes for the light to make the round trip between the mirrors. With just this simple setup, in 1926, Michelson was able to measure the speed of light within 0.001% of its actual value. Today, the speed of light has been determined with such high accuracy that it is used to define the meter. As we discussed in section 1.2, the speed of light is now defined to be c equals 299,792,458 meters per second. However, a value of 3.00 times 10 to the 8th meters per second is adequate for most calculations. In 1865, Maxwell determined theoretically that electromagnetic waves propagate through a vacuum at a speed given by 1 over the square root of epsilon naught times mu naught, where epsilon naught equals 8.85 times 10 to the minus 12 coulombs squared per Newton meter squared, and is the electric permittivity of free space, and mu naught equals 4 pi times 10 to the minus 7 Tesla meters per amp, which is the magnetic permeability of free space. Originally, epsilon naught was introduced in section 18.5 as an alternative way of writing the proportionality constant k in Coulomb's law, where k is equal to 1 over 4 pi epsilon naught, and hence it plays a basic role in determining the strengths of the electric fields created by point charges. The role of mu naught is similar for magnetic fields. It was introduced in section 21.7 as part of a proportionality constant in the expression for the magnetic field created by the current in a long straight wire. Substituting the values for epsilon naught and mu naught into the expression above shows that the speed of light c is equal to 3.00 times 10 to the 8 meters per second. The experimental and theoretical values for c agree. Maxwell's success in predicting c provided a basis for inferring that light behaves as a wave consisting of oscillating electric and magnetic fields. As a final note in this section, we consider the light that reaches us from astronomical objects located great distances away from the Earth. These distances are so great that astronomers use a unit of distance known as the light year. Although this sounds like a time, it's actually a distance. More specifically, it's the distance light travels in 1 year. The value of 1 light year is equal to 9.466 times 10 to the 15 meters. The nearest star to Earth, other than our own Sun, is Alpha Centauri, which is 4.3 light years away. This means that it takes the light from this star 4.3 years to reach us. Thus, when we look at this star, we are seeing it how it appeared 4.3 years ago. In fact, if this star were to explode right now, we wouldn't know it for another 4.3 years. Therefore, when you look at a distant object in the night sky, you are looking back in time, since it takes many years for the light from these distant objects to reach us. In fact, some of the light from very distant objects observed with powerful telescopes, like the Hubble Space Telescope for example, has taken several billion years to reach Earth. Many stars that are billions of light years away, whose light we are observing now, have long since burned out, and in some cases, even before the Earth was even formed.